Here's problem 25-1. A charged particle, Q equal to minus 8 millicoulombs, which moves in a region where the only force acting on the particle is an electric force, is released from rest at point A. At point B, the kinetic energy of the particle is equal to 4.8 joules. What is the electric potential difference, VB minus VA? Let's try to figure out what's going on here. We're going to start off with a charge, a negative charge, a value of a negative 8 millicoulombs. And we're going to start from point A, and we're going to travel to point B. Starting at point A from rest and traveling to point B, and we're told that the kinetic energy at A is 0, we're at rest, and the kinetic energy at B is 4.8 joules. So we're gaining kinetic energy as we move from A to B, as we're starting from rest and going to B. What that should mean is that this negative charge is going up in potential, because that's the way a negative charge would fall. A positive charge falls down in potential, a negative charge falls up in potential. So we would expect that the potential at B would be higher than the potential at A. Let's see if we can calculate this mathematically. Our change in kinetic energy is going to be our final kinetic energy, that at B, minus our initial kinetic energy, that at A. Our initial kinetic energy was 0, so our change in kinetic energy is just going to be 4.8 joules. Our change in kinetic energy plus our change in potential energy should be 0, because we aren't gaining any energy in this situation. All the energy is coming from the field, and that's what's going into the kinetic energy. So our change in total energy should be 0. Our change in potential energy will then be the negative change in kinetic energy, and that will be a negative 4.8 joules. Alright, well, the change in potential energy should be equal to the charge times the change in potential. So our change in potential will equal the change in potential energy divided by the charge. That is going to be a negative 4.8 joules divided by a negative 8 millicoulombs, 8 times 10 to the minus 3. So if we calculate that, 4.8 divided by 8 times 10 to the minus 3, 600 volts. So that's positive, and that represents our final potential minus our initial potential. So this change in potential is actually the potential at B minus the potential at A, 600 volts, and hence that's what we wish to find. The potential at B minus the potential at A is 600 volts. B is higher than A, and that's why the negative charge fell in that direction.